All right, let's get the show started. Hello, everyone. Thank you all for joining. Welcome to InRhythm Lightning Talks. I'm your host, Parag Katkar. I'm the head of consulting practices at InRhythm. InRhythm is a modern product and technology consulting firm, and we have a lot of exciting content lined up that we have curated, especially for all of you guys. Our lightning talks are hosted every Thursday at 5:15 p.m. Eastern Time, and each week, one of our practice area consultants shares their knowledge on the latest technology trends in the industry that will help you keep learning and growing in your career. And this week, Trevor Crawford, who is a senior Android engineer with us, is going to introduce us to Circuit, which is a simple, lightweight, and extensible framework for building Kotlin applications that's composed from the ground up. And I'm super excited to see what Trevor has in store for us. So without further ado, let's get it started, Trevor.
Awesome. Thank you so much. Hello, everyone, and welcome to today's Lightning Talk. My name is Trevor Crawford, I'm going to be diving into some of the details and showing you all a really cool and interesting library called Circuit, which is all based around this idea of using Compose to drive architecture in Kotlin and Android apps. So you're probably thinking Compose. That's Android's new UI toolkit, right? Jetpack Compose. Well, yes and no. Compose is technically two separate things. Compose UI, which is probably the Compose you think of and hosts things under it, such as Android's Jetpack Compose and Compose Multi-Platform. It's a declarative UI toolkit that also has multi-platform support. It's powered by Compose's compiler and runtime, but it's not the same thing. The compiler and runtime are a general purpose tool for managing really any tree of nodes. But we know tree of nodes can really be anything, Compose layouts, Android views, or state objects. They don't have to be, UI. The compiler and runtime also doesn't know anything about Compose UI. The reason that Compose UI is so great is because of the powerful multi-platform state management capabilities that are offered to us by the compiler and runtime. So now that I've covered that, we can dive into some of the details of Circuit, and hopefully this will make a little more sense. Circuit is a Compose-driven architecture for building Kotlin and Android apps. It's open source and developed by Slack, and you may catch some opinionated design choices that reflect that as I cover this. It's used in production in a few parts of Slack's flagship app, and they claim it's ready for general use. But it's worth noting that the API is still considered unstable, as it's quite young and probably likely to go through some changes still. It's multi-platform, aided by the support of Kotlin multi-platform and Compose. But right now, the focus is primarily on Android and secondarily on JVM and desktop. A very recent release added multi-platform iOS targets, but it doesn't seem certain how much support and attention that's going to continue to get from Slack's side. Circuit has a few core principles that I'd like to kind of cover first off the bat. Circuit follows a UDF design pattern, which most Android developers will be pretty familiar with, especially if they've worked with Compose before. State flows down to the UI and event flows up from the UI back to the state handler. You can think of this circular connection as kind of what creates the circuit. It has the advantages of being very understandable and scalable and testable, maybe when compared with other patterns where you may send events to the UI or hold state in the UI directly. The two core components of a circuit are the presenter and the UI. They're both Compose first, and you can see the simple interfaces here on the right. They both have a single composable function. A presenter has a present function that produces the UI state, and a UI has a single content composable function, probably that looks similar to anyone who has seen or used Compose UI before. They are generic types that let you define what type of circuit UI state they communicate with. The symmetrical pattern makes it easy to follow where state flows from and where events originate. And critically, UI and presenters can't access each other. Instead, they can't directly access each other. Instead, they're sending state and events to communicate with each other. We'll also learn more about a circuit screen, which is what pairs the presenter and UI together. You can think of a screen as the key that tells the factory which presenter and UI pairing you're requesting. You can pass data with screens and save them in our backstack, as we'll see once we get more into details on navigation. The last thing to note is that Circuit also heavily embraces a factory pattern, which may look familiar if you've seen Mashi or retrofit libraries from Square and Android, as they're heavily inspired by those. Under the hood, they're using code generated or handwritten factories that create our presenters and UIs, but we won't get too far into the code generation details. So to cover state and events in Circuit, they're defined by two core interfaces, a Circuit UI state and a Circuit UI event, and all states and events in Circuit implement or extend these core interfaces. Circuit UI states are produced by presenters and rendered by UIs. When you have a single state in a screen, these can be as simple as a single data class, as you see in the counter screen example on the right, or they can be a sealed type with multiple options, maybe such as a loading option, a success data class, and an error data class. And you may have seen something similar to this pattern before with Android Compose UI code and documentation. Circuit UI events are emitted by UIs, and they are handled by presenters. Just like states, events can be a sealed type that contain a number of objects and data classes. If you need to pass some value along with an event, you'll see this as a data class, but it can be an object if the type alone gives enough information about that event. Given the sheer number of events that a given screen might have, having them contained in a sealed type will give you really powerful tools to manage and ensure all states are handled, or all events are handled, sorry. You could also just create events for a screen without using any sealed types if you prefer organizing your events that way. Lastly, to note, the events for a given screen must be sent via an event sync callback in the state. And we will see more on a later slide about those details. Circuit UI code is essentially just really clean Compose UI code, hopefully that you're familiar with seeing if you develop with Compose UI. Because Circuit UI just accepts a single UI state in general, it can be really clean. There's no need for passing in a view model parameter, getting the view model from a context, or collecting a state to collect from a state flow. This encourages testability when Circuit requires you to write UI this way, since your UI tests are just simply passing in a different state object to your UI. This type of Compose UI code isn't necessarily exclusive to Circuit, but by using Circuit, you're more or less required to build clean UI this way. If developing with MVVM, you would be able to achieve this, but you may have to expose two top-level composable functions, one that takes a view model and maybe one that accepts the state from that view model, which could quickly become confusing or clutter up your namespace. And you may also notice here that events are being sent to the state's event sync lambda in each button's on click. We'll dive a little more into those details on the next slide in the presenter. But the important part to note is that you see in the buttons on click that the sync is passed an increment and decrement objects, event objects in each respective button. And this is how the UI sends events up to the presenter, rather than being able to maybe do something like calling presenter.add or being able to set presenter.currentCount++ directly, as you might do in other architecture. So in Circuit, presenters are also uniquely Compose first. They do not emit Compose UI, but they do use the Compose runtime to manage and emit their state. This is where you would keep any business logic that you need for your UI or any translation of your data layer. As outlined in the interface on the core principal slide, a presenter returns a UI state using its single composable function called present. Just like UIs, presenter instances are created by a presenter factory. In this simple example on the counter example in the bottom, we don't actually show a presenter class, but you will see that the call to the counter presenter function is wrapped in a presenter of call, which actually makes the presenter class instance for us with this function as its present. As you see here in the top, you'll also likely want to write your presenter logic as top-level classes or composable functions instead of leaving logic within them in the factory directly. This is so that we can easily test them in isolation via unit tests. It's also important to note here that there are three main types of retention offered by a circuit presenter, two of which will look pretty familiar to Compose UI folks. In the top example, you can see remember being used. Remember saves a value across Compose recompositions, and remember has the benefit of being able to take any type. Remember retained is a function that is actually custom to circuit, and it saves the value across recompositions and configuration changes. It also accepts any type, and it's backed by a hidden view model on Android's implementation. And lastly, remember savable saves the value across recompositions, configuration changes, and system initiated process death. And anyone that's writing Compose UI might be familiar with it already. The type for remember savable has to be parcelable, primitive, or implement a custom saver. And it's backed by Compose Framework's save instant state system. In Circuit, a screen is the key that pairs a presenter in UI. As you can see in the top, it's also just a simple interface. It can be an object for a simple screen where the screen type is all you need to know how to request your circuit, such as might be the case with a home screen or a login screen. In more advanced use cases, it can be a data class when a value is needed to request information from your data layer to build your circuit. For example, if you're loading a pet detail, like on the bottom, you might need a pet ID value that you pass along with your screen class. To request these circuits, these screen instances are passed to either circuits navigator or circuit content from circuit navigator from presenters and circuit content from the UI. Circuit content is also the simplest entry point, and you'll see it used as a main app entry point, such as like for a home screen. You may also notice that the actual keyword on the top in the screen interface I'm showing, hinting at that multi-platform functionality I was talking about, and it implements parcelable on Android so that it can be saved in Circuit's backstack implementation. So on navigation, in Circuit, it works using two key components, a backstack and a navigator. It uses really clear and straightforward concepts to reduce the amount of overhead associated with navigation-based logic when compared with other architecture. The backstack is just what you'd expect, a stack of screens. Circuit uses savable backstack that stores the stack of screens and their arguments, allowing you to revisit previous screens that you've been to. Since the screens are parcelable, that means this backstack is savable and can survive configuration changes and process death, so your users won't get booted out to the home screen if your system kills your app in the background. The navigator is just a simple interface that helps you navigate this backstack with three simple functions that do kind of exactly what they say they do. Go to is going to add a screen to your backstack. Pop will remove the top screen from the stack, and reset root replaces the current stack with a new root. Circuit gives us two easy ways testing presenters using presenter test of and presenter.test. The first of which allows you to test a simple presenter function, like on the top. And the second would allow you to test a presenter class for a likely more complex and probably real world scenario. But the internals of both these tests would look the same whichever way you're doing it. In each of these, Circuit's using Cache App's molecule library under the hood to get you a state flow of the states that are emitted by your presenter. And then it's using Cache App's turbine library to parse the flow using functions such as await item, as you can see in both the examples. Circuit also gives us access to a fake navigator, which can be useful in testing so that we can record or assert certain navigation events. UI tests are also really simple because of the state and UI architecture that we've established in Circuit. You simply pass a state to your UI, and then UI testing in Circuit can be achieved the same way as it can in regular Compose UI code with tools like Jetpack Compose UI testing library, to assert that certain nodes do or do not exist with various states. And since you're writing compose code for your circuit UIs, you can also use tools like Paparazzi, which can quickly take a snapshot image of your entire circuit UI given a specific state without the use of emulators or physical devices. And this would allow you to save a baseline of that circuit UI so that you can, given a certain state, so that you can detect any changes or regressions. Previews are also really simple with circuit for the same reason as UI testing. We're simply passing states to our UI. Getting your preview into any specific state that could be achieved in your app is as simple as it is to define the state that your UI accepts. As you can see in these two examples, you can do a 0 and a -1 preview. Android libraries need, great interoperability support to gain traction and be usable probably in most real-world applications. And I think Circuit really delivers here. Because it's Compose first, existing Compose interop tools can be used with Circuit. If you'd like to place your Circuit UI in some old view-based code, you can use the Compose view in XML, as you can see in the top example. And conversely, if you'd like to use existing XML views in your UI, you can use the existing Android view function, as you can see in the bottom example. For interoperability with presenters, the sample Circuit Interop app shows you how you can pretty easily interop from Flow, RxJava, or a straight simple presenter to a Circuit presenter. And in addition, it also shows you how you can obtain a stateflow presenter from a Circuit presenter if you need to kind of work backwards in the other direction. I think Circuit does a really good job of delivering a powerful, clean, and idiomatic compose code in a unified architectural approach that you could apply across an entire app or enterprise, which makes a lot of sense, as this was likely their goal for this to be their future architectural direction at Slack. But I think it's also important to note that Compose is Slack powered, and that probably has pros and cons worth considering before adoption. I think having a huge successful corporation like Slack behind something can be great because of the amount of support and resources they can dedicate to it. But this could also be seen as a potential risk to adoption, because you may have to worry about what happens if Slack decides to move resources away from Circuit. This is especially worth considering if you have, since you have other options like MVVM being supported by Google, who you could argue has a much long-term invested interest in creating a stable architecture for Android. It's probably also worth noting that Circuit is new, and its community is still growing. Slack is using it in their app, but it sounds like it's still going to be a long time before Circuit is the majority architecture at Slack. And this feeds kind of into the next point, that the API is also still considered unstable as it gains traction and adoption. It probably still has some big changes on the way, and if you adopt using it, you should probably be prepared for the possibility of large changes to the Circuit API down the road. And lastly, it's probably worth noting that a lot of these architectural patterns that I've covered here, like unidirectional data flow, model view intent structure, and then declarative programming in general from Compose, are popular architectural patterns outside of Circuit for a good reason. Using these, you end up with something that's easy to understand, concise, and very testable. And if you're looking for this, Circuit is a great way to achieve these and more. So it could be a really smart decision for adoption if you're looking for those sorts of things. Lastly, here are some useful links if you'd like to continue learning more about Circuit. The first is a link to Circuit's documentation. The second is a really great blog post by Jake Wharton about the differences between Compose UI and Runtime, and how probably putting them under the same umbrella name Compose was a questionable decision. And the last two are fantastic videos of a presentation and an interview from two of the creators of Circuit, Zach Sweers and Kieran Elliott. Yeah, so now I can show you a little bit of the some Compose code. So over here, you can see, or sorry, circuit code. Over here, you can see the circuit sample app. I have the counter sample app, 2 of them running. This is an Android emulator running this. And over here, we actually have a JVM app running, for the desktop target. You can see here that counter presenter example that I was walking through during the presentation. Counter presenter is a composable function that returns a counter screen.state. That state is defined down here in our counter screen. We can see that it's using the remember function to retain its count. That is part of that state. And then we can see the event sync handle here with the 3 different events that a counter screen knows about: go to, increment, increasing that count, and decrement, decreasing that count. We can also see the presenter factory and how it's returning for us here. This presenter of gives us back a presenter class object with whatever function we're calling it as the present. You can also see our UI for Android here. Similarly, we have that composable function for counter that's emitting our compose UI code. We can see the event sync being handled here, sending 2 of those objects, increment and decrement, and these button on clicks. And we can see the factory down here that's creating, similarly, our UI object with content, with this body as its content. Something that I didn't dig too much into in the presentation was this circuit config, which is how we tell circuit kind of which factories, presenter factories, and UI factories it needs to know about in order to create those circuits given a certain screen. So for Android counter circuit, it's going to present or provide that counter presenter and that counter UI via those 2 factories. And similarly on the desktop, we have a circuit, slightly different circuit config for that main application that I have running here. And you can see navigation in this simple example as well. Cool. Yeah, that's about all I had today. Are there any questions?
Yeah, great demo, Trevor. I do have a question. Can you back to some demo code?
Yeah.
When you're demo the counter, I think is you using the remember, right? So if it's that's survive the configuration change, or I think is
good catch, Brian.
right?
Good, Brian. No, actually, you'll see if I rotate here.
Yeah, because you're talking about in the circuit you need to use like a remember retainable, right? So that's one.
There's remember retained.
Retainable, yeah.
But yeah, likely here, since this is just a primitive int, we can use remember savable.
Savable, okay.
If I fire this up again, this is, for some reason, this is circuit sample counter presenter used remember, not remember savable. So yeah, now that it's remember savable, we don't lose that count when we rotate our screen. And also, process that if the system were to reclaim resources. But yeah, good question.
Nice. So I think that just depends on the use case, but that's good to know. Another question is for the presenter, it's like one-to-one screen, right? Like I have the counter counter screen, and I have the one presenter for it. Can I have different presenters, like some reusable presenters in the circuit?
I don't think so, because basically that screen is acting as that key in here. So depending, if it was all under the same screen, like counter screen, you're going to get the same presenter. There is a concept in some more complicated samples in their sample app library, where they have these composite presenters, where you have kind of multiple presenters together. But yeah, I think generally, if you're going to have one-to-one between presenter and screen, or presenter and UI.
Gotcha. Thank you.
Yeah, no problem. Thank you, Brian.
Yes, Greg.
Yeah, a fantastic presentation. I love how it's using sort of the tried and true Android Compose stuff to go even multi-platform, but even to just think about that in the broadest terms. One thing about this strikes me is it looks like it's kind of going towards the MVI versus the MVVM structure. I mean, pretty much it is, or MVP a little bit, but in terms of adjusting yourself from the architecture of MVVM, which a lot of us going by Google these days do, what challenges do you think about there is in thinking in MVI versus MVVM?
Well, it's really, I think the big ones are all around, if you want to communicate from your UI, you have to do that via the state, which seems a little weird, but you use the state's event sync. So like, that's the only way you can kind of go backwards and forward, or talk between each other. You can't do like by view model, by view model, whatever sort of Android thing that is going to get you a view model to call functions or things like that. So, that's the big one. But I think that you also run into kind of making testing ends up being easier because of this, because you don't have to create a fake view model. If you want to test any of your UIs, you can just pass a state object, instantiate that, and then that's really all you need to test any UI or create any previews. So that's probably the big one conceptually, the difference, obviously.
Yeah, that's awesome. One other thing I noticed is the one that you have running in the native desktop. It looks like it's using ripple effects and all the normal material UI stuff. Is it all completely supported across with multi-platform Compose, or is that like something a little more different with Circuit?
No, this is, you can, this is all Compose material stuff, like button. It's that same Compose material button library or function.
Oh, okay. So it's using Android X and running that on desktop. Interesting.
Yeah, I believe. Material desktop. That's a good question, but it's not anything particular unique to Circuit now.
Gotcha. Awesome. All right. Well, I will yield the floor for anybody else.
Thank you. Appreciate it, Greg.
Any other question, Brian?
I think my understanding, like using circuits to enforce you using like the MVI patterns. Like if you want to invoke an event, you need to go into like a sync, right?
Mm-hmm.
So like that's more like concise, because we all doing the architecture like between the MVVM or MVI. Some maybe user seekers like doing a really good structure here. That's my understanding. Like because MVI have the unilateral like the single direction, like single source of truth. That's a really benefit to like reducing the bugs, right? So
and kind of what I've heard from the circuit creators interviews is that at Slack they had a bunch of different architectural directions, and like kind of every little guild or group of people working on a separate area of the app kind of solved these problems in slightly similar ways, but ultimately all kind of a different approach. And Circuit definitely is that opinionated layer that's going to hopefully, I think their idea there is that, it's definitely going to enforce that MVI from a single kind of approach for that reason, to kind of, unify their architecture and make it so they're kind of not all doing things slightly differently at such a big, large organization,
Yeah, that's good to know.
Hey, I have a question here. Thank you for the presentation. This is great. I'm a fan of unidirectional data flows. I think you did a good job of explaining things. I actually have two questions here. So one of the questions is, I guess a little bit more low-level technicals, just to understand, is anything special happening within the event sync by any chance, or is it just like a regular Lambda?
I mean, it's just, I don't think anything special is happening. I think it's just running, this Lambda.
Okay, cool. And then I guess the second question is, I think you did mention it during the presentation, some of the drawbacks you had mentioned. I guess it's a little bit Slack centered. And then I guess like resource allocation. I presume like Zach Swears is probably driving this forward the best he can. But I guess that is a concern. I guess the overall arching question that I'm going with is, do you foresee like any major limitations with this that would like prevent wide scale adoption, perhaps? Or
I think that it's so opinionated might make it difficult for certain people to probably get on board and adopt it. Kind of being MVI and having to communicate via that event sync and everything might be difficult, a little bit of a hard pill for certain people to swallow, I guess, maybe. Not being able to call view models or presenters directly from your UI. Also the presenter naming. So I believe that this is MVI, and for all intents and purposes, it is MVI. I think they have that presenter name in these things because Slack is mostly or previously MVP. So that is kind of that opinionated or Slack centered design choice, I guess, that I hinted at. But I don't know. I feel like Compose and UDF and MVI are the way lots of things are going. So I think there's still a lot of potential for a big, large community around it. Even if Slack's not gonna, be the only one using it.
agreed. I do see it as a path forward. And I guess as JetBrains refines Compose for iOS, that's probably like another avenue here where I guess having shared business logic using something like Circuit as the backbone.
Yeah, I guess you could have multi-platform presenters. I wasn't able to get their Swift or their iOS target working. It like really, I think, was like a week ago or maybe a little bit more, 2 weeks ago. They just added that, but I think it would probably need community support to really get a good amount of iOS support, but I think that's definitely possible. Yeah, as Compose goes that way.
Nice job with this.
Thank you. Appreciate it.
Thank you so much. Excellent job with it. And as a reminder to you all, we do these talks every Thursday at 5:15 p.m. Eastern time. And next week, One of our senior iOS engineers with us, Bam, is going to give us an overview of iOS in-app purchases and subscriptions. And I'm looking forward to this talk. Make sure you all mark your calendar for next week. Thank you all once again for joining. Have a wonderful evening, and I'll see you guys next week.